our big goals for today. Big goals for today are to answer any questions from last week. Big focus of today is text mining. We're going to spend 2 weeks on text mining, but really the bulk of what we're going to talk about will be today. And the reason we're spending 2 weeks on it is just because we can. In the past, I had the assignment where it was a lot more intense, and thus 2 weeks was important. The assignment is now less intense, so it could be a week, but we decided to go ahead and keep it 2 and give you a little bit extra time to play around. You are going to get an introduction to text mining. You can take an entire course on text mining. You're getting the 50-cent version of it. But you will be able to do some text mining at the end of the day, so it'll be kind of fun. And then obviously so we made a little change, right? Next week we'll do our project presentations for Project Prep 3. Get you guys some feedback on those. Because then after your text mining assignment, we'll review for the exam next week. We'll have an exam. And then it's all project stuff the rest of the semester.
What's the day on the exam again?
What?
What's the date on the exam?
Oh.
2 weeks?
I think it's 2 weeks.
Wednesday of final week?
Let's double check. Yeah, the 24th.
It'll be the same week that we have the second. I was going to say, it'd be nice to tell you what those stuff before.
Is that good?
I mean, like, 3 tests.
3 tests in the same week?
Well, it'll be
We've
one
got
then
one
and then 2 on Saturday.
We have one more Saturday class exams on the last 50 days.
No,
Yeah,
27.
Okay, you get mine later.
Just trying to plan it all out.
Yes. So that week's going to be study week. Or not study, but I would encourage study. Alright. So, that being said, do you guys have any questions from last week, from your neural network? Questions about the assignment that's due this evening? Do you like the format of the assignment a little bit better? Please tell me you kept it under 5 pages. I don't know if it's exactly 5 pages, but not too crazy. It may have been a little longer, I don't know. Alright, just kind of filling in some blanks. Okay. So, I feel like I have failed you a little bit in my lack of grading. Assignment 7, all but 4 of you, I have assignment 7 graded. The other 4, I will have it graded like during our break. There were a few common things that I thought I would mention about assignment 7, since assignment 8 relates on assignment 7. Nothing drastic for you to change, but just some things that as I've been grading to kind of pull out and talk about. This is also going to help as you go for your final project, which is weighted a little bit more in terms of the writing. Won't help you as much on the text mining, because the text mining is kind of like its own different beast. But when I talk about, when you're doing your data understanding and you're providing insights, visualizations are great. Right? You guys did a lot of some of you guys know some really cool visualizations. Basic visualizations are fine. And basic information is fine, right? You don't have to amazing blow me off the charts with some of the insights. The data set we're using is a churn data set. Right? So one of the first visualizations you might just want to do is, I wonder how many people churn. It's simple, it's basic, but is that an important piece of information to know? Yeah. So for your data set, what percentage of people churn? Yeah, 25, 26%, right? So when you're creating your models, when you're trying to predict churn, when you're looking at all those misclassification rates, what is kind of the baseline that you're using to compare? Yeah, it needs needs to be lower than that 20, 25, 24, whatever it is, right? It needs to be lower than that 25%. So when you're finding models that have like a 30% misclassification rate, that's actually worse than just saying, you know what, everybody's going to stay. So when you start talking about better or worse models, don't forget to go back to your actual data set that you're using and have that baseline kind of in your head to say, this is a great model. Some of you are like, this is a great model. I can classify with 23% accuracy or 23% misclassification. And I'm like, I can do it in 24 without a model. So just something to think about as you keep going along. When you're making your visualizations, a couple more thoughts and reminders. I know it's like, we did that in the last class, but all this stuff still holds. Having an axis, labeling your axes, that's a good idea. You can use the defaults most of the time, but just put an axis on there. Okay? Make sure that I know that I can actually read your visualization. Your visualization should stand alone. Okay? That being said, you don't have to tell me this pie chart tells you the percent of churn. Right? If you created a good visualization, that should be obvious. Right? The things that you get to write, that sentence underneath it, is the insight, right? Yes, it does do churn, so what do you know about this? Other things. Don't forget your units. When you're describing your visualizations, if you're talking about money, tell me it's in dollars. If you're talking about one of the big ones, I wrote lots of question marks. We were talking about in this last data set. The amount of, the tenure was the variable, right? Tenure was in months, not years. So if you said, they've been with us for 70 years. And most of you didn't, it was more like, you're like, a lot of people left by 6 years. It's like, well, yes, but actually they left by 6 months. Okay, it's a huge difference in planning and forecasting. If I can keep somebody for 6 years, I'm probably pretty happy. Okay. So don't forget your units. And then this is just me being picky, but something to think about. As you're talking about, you're making this visualization. You love to use the words clearly and obviously. You can see, of course, these very judgmental words. Because what may be clear to you, because you made the graph, may not be clear to me, especially if you're given axis or don't tell me what the colors mean. Right? So just some things to think about as you go forward into your final presentation. A few more comments and again, your assignment's due tonight. You don't have to go back and change these things. But things to point out, like when you're making your comparison table, when you read the values, like the classification values off the table, it's in a decimal format. But the comparison table that I have is formatted for you to put percentages. So if the column header says it's a percentage, and you put 0.25, I'm like, well, that's great. That's like 1/4%. That's almost a perfect prediction. When really you're saying there's a 25% misclassification. Okay, so just again, units make a difference. Oh yeah, and so this is actually kind of a point, hopefully, to make for your project prep that you're going to be doing, as well as for your final presentation. But when you're choosing your best model, right, convince me why it's your best model. For your last assignment, you had, 12 different models you had to do. For this assignment, you got at least 4 for the neural networks and at least 4 other types. Convince me why your model is the best. And just saying the lowest misclassification rate, I mean, yeah, that's good, but why is that the thing that you're interested in? Going along with that is the idea of the false positives and false negatives. So several of you are like, well, false positives, false negatives, they look about the same with all the other models. And if that's your conclusion, I've got the lowest misclassification rate and the false positives and false negatives are comparable across the models, that's okay. But what is the false positive and false negative in terms of your context, your business context? right? Stop and think about that. So for our example, what would a false positive be?
If some people will churn, but they don't. Churns, but one of the things don't.
Right. Okay. So false positive, right? Okay. So false positive, saying they will churn, when actually they don't. So what would a false negative be? Saying they don't churn, but really they do. So which is better or worse? Well, which is worse? Which is worse for a business?
Depends on the question.
I think you miss them. You miss them if you're.
Well, yeah.
So what is our goal? So I guess, right?
We're trying to find customers that churn. So you want to have more. You want to.
Yeah, agreed.
You want fewer false positives, or you want more false positives.
So more false positives, fewer false negatives. Right?
Well, you want them to be as accurate as possible.
Well, this is true, yes. We want to be accurate, but if we're going to miss, right, so this is really the question that comes down to. Right, so we know our model's not perfect, right? One of the best models that I can kind of write, right, you get like 22% misclassification. That was around the best model that people have. 22% misclassification, okay, that's great. Now the question comes, with that 22%, because there were several that were kind of around the 22%, 22, 23%. Now you look at the false positives, false negatives. False positives, I'm going to say someone is going to churn when really they don't. So what action as a company would I take? I was actually going to use this model and put it into place.
So you wouldn't actually have to do anything special with those customers as they're going to say.
Right, right. But I'm telling you, so my model's telling you they're going to leave. Right? So my model's telling you they're going to leave. So if I'm using my model, then would I have done something to them? Probably.
Probably, but the state rewarded by.
But I wouldn't have needed to, right? So that's the thing, right? So my model says, hey, these people are going to leave you. And I'm like, okay, well, I'm going to go offer them an incentive. I'm going to do something. It's like, but in reality, they didn't. They probably wouldn't have left. Okay? So there, I'm spending resources that I didn't necessarily have.
You can create additional customer loyalty, though.
Possibly, right? So there could be some effects that happen. Okay. So now let's go look at the other way, my false negatives. I'm going to say that I'm not going to predict you as churning, and in reality, you're going to leave my company. So what do? Do I do anything for these people? I want to try to minimize that number, right? So in this instance, we want to find the smallest false positives, right? So if I if I have a larger number, the smallest number of false negatives. So if I have a larger number of false positives, the worst thing that happens is maybe I get some customer loyalty because I'm giving you discounts that you didn't necessarily need. But with the false negatives, I'm not taking action. I'm going to lose these customers because they're leaving. And I didn't know it. I missed them. I had a chance and I missed them. So that's one of the things you want to think through is as you're doing this, what are your false positives? What are your false negatives? And don't just look at it in terms of like the numbers. Okay? But think about it in terms of how is this going to impact our business? So for your final project, something you're going to want to think about. Anything left? And that's kind of the same thing, yes.
So regarding the calculation of false positives, so I just want to confirm if what I did was correct.
Yes.
Is it false positives divided by true positive plus false positive?
Yes.
Okay. Because the percentages came very high and so I was not sure if that's right. Because like some of them had around 50%.
See, and this is what got really crazy, because I'm grading this, and you guys will notice, and I didn't take off points for it, but there's some of you, I will put a comment that says, how did you calculate this? Because it seemed a lot higher than your peers. But it wasn't just like one or two people, like it was about a 60-40 split. Like a lot of people were getting like 20s and 10s and 20% for false positives, false negatives, and there's like a group of people who were getting like 30s and 50% for false positives, false negatives. So yes, to calculate your false positives, the number of false positives, and only when we talk about this. So there's a training data set and a validation data set. Which one do we care the most about? Validation. Yes, got that one right on your test. Good job. Right, so the validation, and so you're only looking at those validation numbers. So it's just the false positives divided by all the positives. So false positives and false negatives. Sorry, false positives and false negatives. Yes.
See, like I had a couple that were like that, but usually they were not really good models because the classification was usually really high too.
And that could be too. Right. So when you had those really big numbers, you probably had a misclassification that was more like the mid to upper 30s, if not 40%. And so for your 22% model, hopefully you have those lower values. Yeah.
Yeah, I had like 20% classification and then also 45%.
Then let's look at it. We'll see. I mean, that's the best way. So if you know the formula, then we'll just have to look at it and see what's happening. But yeah, so then the last thing was just with your pitch, and this goes with everything, right? Make sure that you kind of state your business question so we really know what you're looking for. Don't get into the process details about your model, but do talk about, hey, this is a good model, and it either maximizes false positives or minimizes false negatives as it makes sense to your business question. And then don't forget all those descriptive statistics that you had. Feel free to use those in your pitch to kind of make your point, right? Because all your model is telling you is we can classify or we can't classify, but it's hard to take action on that. So go ahead and use those descriptive statistics if you want to flesh out your elevator pitch a little more.
As far as the project is concerned, this only applies to like the classification, right?
Yes.
Not the estimation.
Right. Yeah. Your estimation, the best way to kind of do that is like, here, let me give you an example, and this is what we can do. So any questions or comments about?
Yes, kind of connected to what Frida asked. The misclassification rate, that should kind of be basically the false positives plus the false negatives, right?
Over the total. Yes. Good. All right. If you have questions, ask away. If not, enter our foray into text messaging. So we've been a lot of places. Right? We're still following this lovely crisp process. You'll see this again in assignment 9. We've done supervised and unsupervised data mining tasks. Or sorry, we had supervised and unsupervised categories. And into those categories we had estimation, we had classification, we had clustered, we had association, we had all these data mining tasks. But all of this that we've done so far, yes?
I'm sorry, but did you just say misclassification rate is equal to the percentage of false positive plus percentage of false negative
Divided by the total, yes.
divided by the total? Okay.
You good? Yeah, yeah. Yes, false positive, false. What you got wrong? So false positive plus false negative divided by the total.
So to clarify, it's a number, not a percentage. She was asking the
Yeah,
ratio of the
I thought
percentage.
you were saying it's just the sum of percentages.
No.
And that's okay.
No.
Yeah.
It's calculate, to calculate, it's the actual frequency of the false positives plus the frequency of the false negatives. Yes, not a sum.
This is small tip for the next year's assignment. In that table, if you could actually have true positive, false positive, and all the 4 as well, then if some mistake happens in the calculation, right, it will all go back. You can do an Excel formula and get everything right. So if they capture the individual values, because I did the mistake, I made true positive as when false positive divided by the total. I did the entire table, then I realized the formula was wrong. So then it's easier if you capture the individual, so even the formula is wrong. If you want to correct it, you just correct it at one place.
Well, no, I totally agree with that. Because, so this was a format that I used from last semester, and in the previous, you didn't have to necessarily calculate it by hand. And so it wasn't as big of a deal. Like SPSS gives you all these calculations, so I'm like, oh, just plug it in. I did not realize that you guys were going to have to calculate that all by hand. I absolutely love the idea of creating like an Excel book, an Excel spreadsheet that does the calculations for you, because I think that's going to be a whole lot easier. So yes, I love that. I actually have that updated in mine already for next year. That's wonderful. Any other great ideas? Other great ideas? Alright. So we've been a lot of places. And all the stuff that we've done so far this semester, though, we've always had structured data. So all of these things we've done so far have been with structured data. Today, we're going to try some unstructured data. We're going to have some text. Okay. We're still going to follow our CRISP process. We've done all of these wonderful things. So supervised and unsupervised, all of these things, great, wonderful, but we've all had structured data. So when I say structured data, everybody knows what I mean? It's in a table, right? An Excel sheet. Not necessarily, we'll use an Excel sheet later, right? But it fits, we have columns, we have
Something
quantifiable.
Something that has a structure that you can define, something that you can query.
You can query it, right? It can fit in a database. It fits in, like what you really think of as an Excel sheet, columns and rows, right? Not just a string of text. We're going to play with a string of text today and see what we can do. We've kind of already talked about this. I'm working on the grading. We'll get that done. So where we are now is unstructured data. So let's see if this works or if I forgot to download stuff. They updated my stuff. Okay. So my question that I have for you, we're going to start out, we're going to play a little game. No, I can play games. I totally forgot to update this last time. That's good. 1 second. It's supposed to just pop up on my PowerPoint. Alright, so here's the fun part. Everybody has to close their eyes or else it's going to totally give away my secret. Oh wait, one from this. Oh, I can. Great. Okay, we'll just do it this way then. Perfect. So what I'm going to have you do there we go. Is on the machine in front of you. It's pollev.com /ekeeper078. pollev.com /ekeeper078, and you get to answer the question of what is your favorite music genre? And pop. Just popped right up there. And classical. We're starting to get some results. What do we have here? What is your favorite genre of music? Alternative? Alternative? Pure melody. Rock's getting a little bit bigger. Afrobeat. Alternatives growing a little bit. I mean, you guys are just awesome now. I don't know who wrote it, but somebody's going to have to demonstrate it, so. So it looks like pop is kind of winning right now. Indie's getting a little bigger. Rock and alternative. And so we have alt and we have alternative. Same thing, different thing. What do you think? Probably the same thing. Maybe that doesn't help. It doesn't make alternative any bigger, so it can go against pop. Slow, full. -1 for jazz. Really? Jazz, -1 for jazz. Now we're just getting funny. Indie and French. So indie's still kind of up there. Pop, rock, alternative looks to be kind of the big ones. So this is just, I mean, a very quick and dirty word cloud helping us with text mining. Right? That's what we're doing. All we're doing is just the size of the word grows as the frequency of the word is typed. And this was a little bit biased because obviously you guys got to start typing things after you saw some of the results, i.e. -1 for jazz. We noticed we had alt and then we had alternative, so that we typed in words that probably meant the same thing, but they didn't categorize correctly because they weren't exactly the same. I love that you guys all ran the words together and didn't like put spaces. Right? So what would happen if you would have put a space? It would have been it would have been Mongolian throat singing. So unstructured data, right? It's there. What can we do with it? Let's see what my next poll is. I really love there's 32 responses because there's not 32 of you in here. That's awesome.
You need to get it right the first time.
All right, so now I have a very similar question. What is your favorite genre of music?
We don't have to refresh the window.
I don't think so. Oh, I have to activate it though. There we go. What is your favorite genre of music? Pop still got out there to the front. Rock's making a game for it. We've got a few on the others. That went a whole lot faster. You had less choices. Yeah, I think you only get to respond once. Okay. So now when I limit your choices, now I can actually say, you know what, pop really is, out of this class, what people list for, what their favorite genre is more than the others. Rock comes in a second, with other coming in third, because we can't -1 for jazz. Structured data, right? Nice, structured, easy, it's there. Okay. Which do you like better, structured data or unstructured data?
Unstructured is better to work with. It's more fun.
Unstructured is more fun. It's easier to work with structured.
You look at it this way, that the unstructured can give you more information, better, deeper insights.
So maybe I get more information from the unstructured. But how do I get the insights out of the unstructured data?
Text mining.
Text mining, yes. So like, I don't know now, but by the end of the day, hopefully I know something. So I mean, that's kind of the goal, right? Is how do we take this unstructured data and get the essence of it, what we really want, what we really need. Okay. This was pretty easy. You guys only have to type in one or a couple of words. Okay. When you have documents, or when you have more information, how do we get what we want out of it? So first, my little intro thing, and then we'll actually play with some data. We'll see what happens. So I couldn't help myself. I did have to do a word cloud. These are the objectives from this course. So, since it's a data mining course in essence, it's a good thing that data is our biggest word. Hopefully we are explaining, we're doing a lot of data tasks. The business is hopefully coming through. But then you'll notice a lot of the other words are very similar in size because we only spent a week on each different topic. So there wasn't another thing that really kind of came out. It's a lot of decisions. So when we talk about structured versus unstructured data, we kind of have already done this. Right? We've had the numerical, the binary, right? That's our structured data. We're moving on to unstructured data. Text mining, really the idea is just looking at text from natural language, right? So natural language processing is becoming more and more and more popular. That's kind of what we'll talk about a little bit more next week. But I mean, how familiar are you guys with natural language processing? Heard the term, so that's the place to start. See what?
Interview with the company who does it, but just do the job.
Okay. So natural language processing, how many of you guys either own or have experience with Alexa or Google or Siri, right? How do they, you talk, you get an answer back. It may or may not be the right answer, but you generally get an answer back, right? And that's the whole idea behind natural language processing. It's hearing the words, taking those words, turning them into something that a computer, or in our case, an algorithm, is going to be able to understand that we can use and then help make decisions, give us the response back, and explain it again. So the natural language processing. So with the text analytics or the text mining, really what we're trying to do, there's kind of like two major fields, if you will, or two major subsections. One is the idea of just classifying documents. Right? Just taking a document and just classifying what it is, where it fits, where certain terms are coming from. And this is really going to be our focus. Okay, so we're going to have a fairly narrow focus because we're only spending 2 weeks on it. Our job is if we have a document, if we have just some text, a sentence or two, can we correctly classify this document? Okay. This is really the extension of predictive analytics. So that's what we're going to focus on. There's another set where the natural language processing comes in, and this is when you're actually trying to get the meaning out of a document. Right? You're trying to interpret the document. It's a very ambitious thing, right? What does this mean? Can you summarize this? We're just going to say, can we classify this and get it in the right spot? So one of the examples I use for this is there's a whole different idea in, let's take the legal profession. Okay. Legal profession, you get a lot of discovery during trials. Okay, so discovery is just all the documents and everything that pertain to the trial that the lawyers are working on. And wouldn't it be nice to, when you get all this information, to be able to feed it into a machine that can then classify it as, this has really nothing to do with your defense, this is really important for your defense, and maybe even I'm not really sure, because I'm a computer, maybe some human needs to look at this. Right? Wouldn't that be great? So instead of having boxes and boxes, hundreds, maybe even thousands of documents and pages and pages and pages to go through. Really important. I'm not sure someone should take a look. Okay, but all you're doing there is just classifying a document. You're not trying to actually draw the meaning of it. Trying to draw the meaning of it would actually be if a computer could provide like a summary. Right? Computer, just read this 100 pages, and let me tell you the salient points. Here's an executive summary. That's more the extracting meaning piece. People are getting there. We're not going to get into. Okay. So our goal is going to be the classification. We're not going to attempt to get the meaning. We're going to assign a label or a class to it, and then our goal really is just to do better than guessing. Right? So if we can do better than 50-50 or whatever the right proportion is, that's going to be our goal. So why text mining? And I always hate when I put this number on a slide, but I'm going to. Because it's there. Text, unstructured data out there in the world. Okay. What are other forms? So I keep saying text mining, but what are forms of unstructured data?
Music.
Music, media,
Phone conversations.
phone, video. So text definitely fits in there. Pictures. Data is out there in all sorts of forms. I think about it on Thursday. Write myself a note. It's out there in all sorts of forms. So we are going to focus more on the text mining. But then as we look at this text, how do we get that into a way that we can actually use to do analytics on, to make predictive decisions on? So why text mining? Why now? Just to better understand what's going on. If all this text is out there, why not use it instead of just catalog it? Why now? Because we can. Right? We now have the computing power. We're trying to get into this information, right? Businesses now tapping into this text mining stuff, it's not an option anymore. Right? You have to do it. Okay, to be competitive. Right? Think about, I'm sure none of you have done this. Right? But you're not happy with a product or you're not happy with something that's happened. Then you go out on their Facebook page or Twitter and you may post something. Maybe you get a response, maybe you don't. Some companies are very great at this. Some companies are very funny about it. Wendy's. And I need to add some Wendy's captions right here. I think that's probably pretty good, right? But you do, you go out and post something negative on an airline, and a lot of times somebody is there monitoring your entire job is just monitoring the Twitter feed to find out when people are complaining about your airline, to see what you can do to fix it, right? It's not optional, right? We've got to do this. And how can we do this? Do we want somebody just to sit there all day, read all tweets, right? Natural language processing. Don't worry about it. Don't worry about, hey, look at these. Yes?
I'm told that Hollywood, the way they vet out storylines is, it doesn't go to the director first. It's vet by a computer multiple times, and the computer decides what is the structure of the story and whether it fits into, whether it's fit to be considered. Then it goes to humans.
That doesn't surprise me at all.
That came as a total surprise. I mean, it was mentioned by many actors, directors, and even from India. They said that this is the way, this is the future, and this is the way all the large producers, all the corporates, they do it.
Because you're getting so many, right? You get so many. It's like, let's bring this down to something that you guys really care about right now. What other thing goes through a computer before it gets to resumes? Right? Right now, resumes are going through, some type of computer machine learning, natural language processing, saying, do you fit? So it used to be, you had to get in front of a recruiter, and so then how do you make your resume look really, really matters. Oh, this looks nice. This part, not this part. Now you've got to get past the computer, right? So that's why you guys all have the handshake, and you have access to some of these things to kind of help you figure out, yes, my resume is going to have those keywords, right? To be able to get past the machines, and even just to the first round of it you're looking at. Is it fair? Probably not. This is the way the world works. Let's be real. It's not fair at all. Just because biases are crazy. I won't go too crazy into this, but Actually, I'll show you the video. I have so many videos for next week. Right, I'll show you a video next week of when, I'm trying to remember, it was Tay IBM? Trying to be like an automatic bot that was going to respond to questions. And they trained it off of Twitter.
Oh, I've seen that.
Is it the one where
It became
Microsoft?
It became
Is it
like
Microsoft?
a
It's
white-
Microsoft Tay. I couldn't remember which.
And it became like super like vulgar, like
It's
attacking people.
Incredibly, it was vulgar, it was racist, it was a horrible. And it trained it on Twitter.
Yeah.
And so one of the great comments that you learn is that it had nothing to do with machine learning aspects. It was the input which came from
Racist people.
humans. Right. So what we just found out was that Twitter is a very vulgar, racist place to go.
Well, they based it off of people interacting with it, and once people figured out that it was like being tested,
Yeah,
they
did worse. Yes.
they went way to the opposite of it. Yeah.
They did do worse. I mean, there was some, I don't know, yes, it was probably malicious intent. But the whole idea, again, kind of behind this text mining, this data, this natural language processing, it's out there, it's manipulable, right? So we have to make sure that we train our data well. Right? So the idea and the processes that we've been doing all semester still become very important. How are we going to train our data? So what's happened, and again, this is just kind of stuff, I mean, it's a dated slide. It used to say trends, and then I changed it to what's happened. Right, because it's out there. We're doing it. We've got text analytics. We've got social media. Like everything's out there now. We've got to use it. We've got to waste it. The use cases are vastly. I mean, they're coming up. They're popping up every day. Social media analysis. You love our churn analysis, right? I'm not going to make you do churn for the text because that would just be crazy. I know you guys are tired of churn. Right, but churn analysis. If we had that one piece of like, what could we do if we had more information about churn? Right, several of you guys are saying, it's an okay model, but if I had more, right, what is that more? Right? We didn't have in this particular data set, we didn't have the customer call info, like how many times you called the service desk. But if we did, and then we had a transcript of what you called about, right, so then not only do we have just a number of yes you called or no you didn't, but yes you called and this is what you talked about. Might that enhance our model? One would think. In fact, that's actually what we're going to try to do for your assignment. Okay, so competitive intelligence, categorizing your documents, fraud detection, medical research. All right, medical research is definitely, I'm sure at this point you guys have all heard about IBM Watson predicting cancer. Right? I never know. It's like I always have these stories, and everybody's like, "Yeah, I've heard that story like 5 times now." Right. So, I mean, we talk about unstructured data. Right. It can be the idea of images. Right. So Watson can actually help, and it could be actually when we say Watson, it could be any other, AI intelligence that we're using with machine learning capabilities. There's so much medical research that's out. Doctors can't keep up with all of it. But wouldn't it be nice if it was all fed into a database and then you can query as needed? You can help using these predictive algorithms to help you learn. Like, it may not be the final diagnosis, but why not use some of this to help aid your decisions? Right? So this is the boring part. But we need to know these next 2 slides just because as we talk about stuff in the next 2 days, or next 2 weeks, when I use words, you need to know what words mean. So I kind of took everything out and kind of made 2 slides that were just the terminology. So when I use it, you can kind of go back to this. A corpus is just going to be our collection of text documents. So whether that is sentences in a book, whether that's a collection of books, documents, whatever, it's going to be a corpus that we're going to use. Instead of using the word term, or using the word words, we're just going to call things terms because that can include words, digits, anything that we want it to. Tokens. You guys are on, most of you are in blockchain stuff now. You guys do tokens. How do you use tokens?
Digital representation of something.
Okay.
Currency asset.
We'll be doing kind of the same thing, right? So a token, we're just going to use it as a digital representation of, most of us is going to be for a string of words. Right? So instead of a currency, it'll be just for a thing. Stemming, right? We're going to be finding root words. We'll have stop words and include words, things that we will, as our text is reading, it'll either include or get rid of. We have to think about the idea of synonyms. When we have words that mean the same thing, how do we categorize those? So we talked about terms, which is going to be single words. Concepts, we can put multiple words together, right? So we have data, which means just raw values. We have mining, which could mean anything from ore out of the ground, right? Coal mining. Mining means a lot of different things, but data mining means something more specific, right? So a concept. We'll have a term dictionary. POS in this class is going to stand for parts of speech. Very clear. As opposed to other representations of those words that you may have seen, parts of speech, please. We'll have a term by document matrix. We'll have a thing that's called singular value decomposition, and you'll see these letters. And then we're going to have LSI, which is a latent semantic indexing, and we're going to use this. This is going to be the math behind, this is the math magic that takes unstructured data and turns it into structured data. And then the big idea is going to be kind of the steps in our text mining. So as we're going to do this, step number one is we have to get the data, right? We've got to collect the data. We have to create a corpus of documents. In the past, we've actually made this kind of a semester-long experience where we had people going out and getting stuff off the web and kind of creating a corpus of documents, and then we actually tried to do this. This semester, I'm just going to give you generally Excel files. I'll show you how to do it with just a bunch of files, but it's just a data collection piece. The text parsing and transformation. So this is what I was saying. This is taking the unstructured data and turning it into structured data. I put magic in quotes because sometimes it's what it feels like and sometimes what it looks like. But we're basically going to be using linear algebra. We're going to create this thing as a term by document matrix, and I'll show you what that looks like here in a second. We're going to use singular value decomposition, which is, you can basically think of it as like principal components analysis for text. Okay? So we're going to be doing some dimension reduction. And we're going to get this, all this text will actually be transformed into numbers. Because when we have it in a number, and we have it structured in numbers, now I can use that in my data mining. I could do a decision tree. I could run a logistic regression. I could do a neural network using this text once I get into a numerical structured format. We'll do some text filtering. And the text filtering is where this helps to be like a domain expert. Right? You can actually go in and say, oh, this word means the same as this word, it's a synonym. Oh, we really don't want to use these words, kind of thing. And then we'll actually do the text mining, because now it's just, text mining really is just traditional data mining that we've done all semester long, after we've taken the text and turned it into numbers. This is kind of our big process with the steps in the text mining. We're going to use Enterprise Miner. We were going to play with VIA, but I decided not to. We're going to stick with Enterprise Miner. It's going to do all of this for us. Our big job at the end is just going to be to interpret the text mining, to interpret some of the results. So going back with our CRISP-DM process, we've got our business understanding phase. So our business question we're going to ask, I know you were really excited to continue with eBay, but I'm going to change. We're going to do something different. Okay? Whether animals sport. Okay. So this is a completely contrived example, but we're trying to use it to illustrate text mining. So what we're going to do is we're going to have, we're going to call them documents. They're really going to be sentences for illustrative purposes. And we want to decide, does the sentence or two that we have correspond to weather? Is it talking about animals, or is it talking about sports? That's our goal. Can we classify our sentences? Can we classify our documents? So the data set is going to have two fields. One is going to be the text field. That's all the information that we have. The other is we have to train our data set. Okay, so that part doesn't change. We still have to be able to train it. So you can't just automatically, for our purposes, give SAS a bunch of data and say, hey, try and figure it out. Right? If we want to try to classify, then we have to take a subset of our data and provide the target variables to be classified on. Okay? So here's some of the data that we have. So record number 2, Bob has 2 dogs and 1 cat. The cat's bigger than either of the dogs. Is this an animal, sport, or weather? It's an animal sentence, right? Come play baseball with us. Sports. During the winter, the sun's lower in the sky than it is during the summer. That's why winter days are colder than summer days. They're pretty obvious, okay? But what about this one? And I know this is a little dated. Carmelo Anthony scored 42 points for the New York Knicks basketball team to a win over the Florida Pelicans. So if you had, so if you had to pick one, if you had to pick, is it animal, sports, or weather? It's really a sports question, right? We're talking about a basketball player. So the fact that we happen to have an animal because it's a sports team's name, why not use animals for sports team's name? Right? It really is a sports scenario. Okay? If you like hot weather, the Arizona desert is very interesting to visit. There are lots of unusual animals living there, including wildcats and boars. Animals, sports, or weather?
The same thing as the hot weather.
It's not more. It's kind of more about the weather though, because you're only going to do that if you like the hot weather. Sure. Like that's the main crux. The subject is the weather. Right.
And then we support with just more information about hot weather?
It's like it's about the hot weather, and these are more reasons to go here if you like the hot weather.
There's only one. It's just hot. There's only one word about it.
The creating the scenario is the weather.
Yeah.
Like that is the starting point of this.
But I'm a computer, and I see animals, wildcats, and I see 3 animals. One weather. Okay. So I did go ahead and I classified it as animal. You guys were like, no, that should probably be a weather sentence. These are when it gets more confusing, right? This is where our misclassification happens. So this is where, in all honesty, we might have an animal, weather, sports, human check, right? Kind of looking for those, I'm just not really sure, right? So if you can clearly classify it as animal, weather, sports, that's great. Here we could clearly classify, this is definitely a sports thing, right? Here it gets a little more interesting. You can kind of get into some stuff, okay? So that may be, maybe we create a 4th category that's human check, okay? In the data set, it's animal. You're just going to have to deal with that right now, because I'm not going to change the data set. Okay. So our business question is, can we create a model that's accurately going to cluster text into our specific categories of weather, animal, or sports? Okay. Like I said, this would be the lawyer's example of classify it as I don't care, I care, and somebody can look at it. Okay, so we're just trying to classify our variables. So the data prep phase. So this is where in the text mining, we get our data, we're going to parse our data, and we're going to filter our data. These are our 3 kind of big steps here. So a little bit of how this works. Okay. We're basically going to take all of the words in the document and create what we call a bag of words. Right? I'm going to get rid of the syntax. I'm going to get rid of punctuation. I'm going to get rid of grammar. Right? We've got a computer. It's smart enough to know that any form of the word is, are, was, were, be, being, been, all of those things are basically the same verb. Right? The computer's going to be smart enough to know. If I see this, then it really fits into this category. Okay, so the document is considered a bag of words. It seems like it wouldn't work because you're just, now everything's just all jumbled up. But really, if all of our goal is at this point, it's just to classify, right? We're not trying to find meaning. We're just trying to classify. This approach works really well. We don't need 100% accuracy in all the words. As long as we get it into the right category, that's what matters. So how this is basically working, we're creating this term by document matrix. So the terms go across in the columns, the rows are the different documents. So here I've got two different sentences. Okay? So I've got first we consider the spreadsheet model, and then we consider another model. So across the column I have first, and that happens once, we consider the spreadsheet model. All of those happen once. Then I have then, and that's a new word, so it wasn't in the first sentence, it is in the second sentence. Then, and I go back, we consider, we don't have to be, we don't have spreadsheet, model happens, and another. And you do this with every sentence, and you create this crazy, long, huge, you see why we need the variable reduction? Every single word that appears in a document now has a column. That's crazy. And generally, each word is going to be preceded or followed by a space or a period, some type of delimiter. Yes?
What if you have like multiple languages?
In the same document?
Yeah. Or would you just assume you translate?
So I would assume that if there is, like if it's just a word, like, right, like a name, or like they used chow, like the suspect always said chow, then I would use it as a word. But if it was actually like, here's an English text, and here's some Spanish text, and here's some English text, then I would translate.
I was thinking like comments on like a YouTube video or something.
I would translate.
Sometimes there'll be one that like in Arabic or something.
Yeah, I would translate. So I want everything in one language.
Just like simple.
Yeah. That's a great question. Yeah, so obviously real text is more complicated, right? I gave you like a simple sentence, a couple simple sentences. Things we have to think about though, right? So different languages, right? Different symbols altogether. Then we've got to look at something totally different. Here, this is still the English language, and I'm going to come up with issues. Numbers. Numbers are problematic. You don't have to be able to read all of this in detail, but just kind of pointing out some of the numbers, right? I've got 20%. Right? So it's a percentage. I could have written out 20 and then the space and then the word percent, and those would be technically classified differently. I've got December 31st, 2013. Right? Well, that whole thing needs to stay together. That's a point in time. Right? I don't just want a number 31 and a number 2013. It's 2013, it's not 2013. Right? They have different meanings. That's not $4. Right? $4 versus $4 million, a huge difference. If there's anything else. Right, so those are just different things that we're going to have to consider.
Yeah, there's typos.
Type? Are you saying that I have typos?
It says 20,000 there.
Right. That may turn out as a number, but really it's a typo. Right. That's another thing we'll have to, when we get into our software, we'll look at, do we care about spell check? Okay. Do we want to try and fix the spelling? Do we want to be like, I don't know, it is spelled wrong? These are all the things we'll have to consider. Okay. Email addresses, websites. Oh, these are always fun. Right. How do we handle all of this? Right. So this crazy email address, websites just get crazy. It's kind of smaller. What do all these equal signs mean? I feel like you guys don't know. Yeah. Alright, it's not like the HTML text. Alright, so now if we're trying to mine HTML text, well, how do I know what do I keep, what do I get rid of? So things to think about. Proper nouns, terms specific to a field, right? So here we're talking about Camtasia, Camtasia Studio, Camtasia Relay. Those really need to stick together. That's not 3 instances of Camtasia and 1 instance of Studio and 1 instance of Relay. Right? It's all a Camtasia product. Medical journal, always fun, right? Femoral neck needs to stick together, right? It's the lumbar spine, right? Those words need to stick together. They're terms specific to a field. So these are all the things that we'll need to think about and figure out how we want to do this. We're not going to focus a lot on it because we're doing animal letter sport. But things, if you are actually going to do this text mining, that we have to really consider. So we need to move from a mass of text to some useful information. The first way we're going to do is we've got to identify the individual terms, right? And so this is where some of the tokenization comes in. And we'll talk about, I don't know why I have this extra slide here. But to start out with, we have all this data, and we're really going to pre-process our data. We've got to get our data into a format we can actually use. So we're trying to do this text reduction. We're trying to, I mean, this matrix is going to be huge as it is. So any words that we can consolidate, the better. Okay, so stemming happens a lot, right? So travel, traveling, travel, any form of the word travel, we can condense. Okay, because whether it's happening now or in the past or in the future, we're still just talking about travel. Okay? And that will help us decide which category it belongs in. For the most part, we can ignore the case of the letter, right? Because we don't want to say, then we do something at the beginning of the sentence, versus in the middle of stuff, I did this, comma, then I did this in the middle of the sentence. Right? That's still then. Whether it's capitalized or not, it's still the same word. We also employ like filters, right? So words that happen all the time are not going to help me cluster documents. Right? Well, this happens in every cluster, so I don't need that. Same thing for words that rarely happen. Okay? Sometimes we may filter out words that they only occur in just a couple of documents. Okay? So we can apply different filters. All sorts of ways to kind of pre-process our data. Punctuation is some type of delimiter. I don't really care. Exclamation point or period. I don't care how excited you were when you said the sentence. We still moved on to the next sentence. A lot of defaults, if you have words that are 2 characters or less, you kind of get rid of them. Right? Is, it, a, of. Those aren't words that are going to help us. Right? So I have a 3-year-old little niece, and I mean, she can talk now, but as she was learning to talk, right? She can communicate very well without all those 2-letter words. Aunt Beth eat. I knew exactly what she needed. She didn't need more words than that. Right? I knew what she needed. That's kind of what's happening here. We're trying to take, if you want to think of it, take adult language and turn it into baby language. We can still figure out the essence of what's happening. Okay? Other things that we have, we can also drop terms that are on a stop list. So we can include terms that we want and say, you know what, if you see this, just get rid of it. I don't need it. So common words in my field. Right? Education is probably not going to be a word that I need to use. It's going to happen in all of my documents. You can get rid of it. On the opposite side of that, you can also have the include list. And someone mentioned this in my Saturday class. If our default is to get rid of 2-letter words, we get rid of the word us. But especially if I'm doing international business, that could be important. Right? So maybe us is a word I want to keep. Because remember, like in the last slide, we said we're ignoring cases. Right? So it would see US, us, little us is us, and big US as us, because it doesn't see cases. So we want to say, no, that was an important one, we need to keep it. When we talk normalization, this is a fun one to talk about. So have you heard the word normalization before? Oh yeah, good, because I taught it to you. So when we did normalization in the past, when we had our structured data, what would we do? How would we normalize a variable? there was like a formula that we kind of used. You normalize a variable, standardize a variable.
Oh, yeah, the methods, standard.
I think. Right.
For
So-
a moment, my mind went to normalizing the data.
So yeah. So just normalizing a variable, it would just be like in the past we've talked about either standardizing it on like a 0-1 scale, or for me when I say normalization, I do that z-score, right? So normalization on a structured variable is kind of a z-score idea. Here normalization is basically going to be saying we're going to start to use tokens. So I don't need to know the exact email address. I just need to know that it's an email address. Right? So John, I don't care what the domain is, .com, .edu, .org. Right? Anything that looks like this, I'm going to call it an email. Anything that looks like www.domain.com, right? Whatever it is, that has a .com at the end, or a .edu at the end, or a whatever we need to put at the end, we're going to call it a URL. Okay? So again, we're just trying to streamline our process. I'm not going to get into the craziness of the post-production matrix. Our rows are record, our columns are terms that we're using. We're basically trying to shrink it as most as possible. And the idea is we're actually going to be calculating something to find out, does this term happen a lot, or does it happen a little? The bigger the numbers, the more the term happens. The littler the numbers, the less the term happens. And then once we have that, we've got this. So we started with this term-by-term matrix. We reduced it. Now we're doing this thing that's called latent semantic indexing. And really this is kind of like, I said, kind of like principal components analysis. Right? So what this is doing is it's looking for similar concepts. Right? So things that seem to be happening a lot together. We're looking for similar concepts. So instead of just having data mining, we're having data mining. Okay? So that's the idea behind the semantic indexing. Let's see what it is. Yeah, so, I mean, this is just kind of a written out example. I hate reading slides, but I'm going to. If we inspected our document collection, right, we might find each term, or each time the term alternator appeared in an automobile document, the document also included the terms battery and headlights. Because generally one of the first ways you know your alternator went out is when you lose your headlights, because it's the thing that makes you electricity again, right? On each time you see the word brake, you also see the words pads and squeaky. So now, there's no detectable pattern regarding alternator and brakes. Those are two separate parts of the car. And so now, documents including alternator might not include brake might not include. So of the four terms, battery, headlights, pads, and squeaky describe two different automobile repair process issues. Really, we have failing brakes and bad alternator. So what we're trying to do with this latent semantic indexing is we're really trying to find out, okay, all these words kind of happen together. Can we summarize this into a concept? And that's what's happening behind the scenes. SAS just uses this, and we get to say, oh, this is great. Extracting meaning, we could try, but really this is just going to be kind of crazy. So the key contribution is simply the idea is just we're reducing the vocabulary. Right, we're pulling it down. So instead of having this matrix of thousands and thousands of words, now we just have a matrix of 1,000 words. So we're making it small. It says down to a dozen or two. I don't see that actually happening a whole lot. This is what it turns into. So we're basically taking words, come play baseball with us, and turning it into values. Most values are going to be between -1 and +1. And then this will be the structured data that we can actually use in our predictive models. You want to sit down? Sorry, that's not on the right slide. We're almost in. All right, so our predictive models, right? So now we have this clean structured data set. We have numbers. We can actually plug it in and do some identification. We can do some simple. guys want to take a break?